Assalamualaikum and hi to my presentation panels. My name is Siti Aisyah binti Badrul Hisham. I am from 3 BMMA 2/1. So here is my final year project presentation or PSM1 presentation. My project title is Development of Lightweight High Strength of Flexible Structure for Underwater Sensor Holder using Selective Laser Sintering SLS. My supervisor is TS Muhammad Zakaria for supporting and assisting me with this project throughout this semester. And this is me, Siti Aisyah. This is my presentation outline that I will explain more details after this. Okay, next for project background. This project will be conducted together with Perbadanan Pembangunan Sungai dan Pantai Melaka (PPSPM), which will cover 9 kilometers length of Sungai Melaka from Batu Hampa, Peringgit to Sungai Melaka near to Bandar Hilir. This is the conjunction with the effort State Government of Melaka and also PPSPM to sustain the water quality and clean of Sungai Melaka. Since Sungai Melaka is an attraction of Melaka and a lot of tourists from around the world and Malaysia come to Melaka for holidays. Hydro Quality Survey or Hydro QS is a device for water quality monitoring system that can monitor and analyze the water and trigger notification if the reading show unusual figure. As Hydro QS integrated with IoT, all the data can be monitored anyway via apps or through phone. It also can be used as to detect water level of Sungai Melaka and send the data through the phone. When working with water, the product need a lot of characteristics need to be considered. The flexible structure for underwater sensor holder is to measure the water level of Sungai Melaka. Accurate data given are needed and depending on the design lightweight, height strengthness and material chosen. These two main things need to be focused in this project, which are the material and the design. The flexible structure with sensor will be clicked on the in front of the mini riverboat and move from the riverbank to another side of riverbank to take measurement of water level and river contour. The sensor that we will use is seismic sensor, and the sensor need to be within the water surface to give accurate data. Okay, next, for the problem statement. Every project or development starting with problem statement so that we can come up with objective and the scope. For this project, the first problem that we figure out is the sensor holder will click to the riverboat while moving to take the data. So it is need a very high strength to prevent from fall and sink into the river. The mini boat will move with 30 km per hour until 60 km per hour with the sensor holder click in front of the mini river boat. The boat will move around 90 km of Sungai Melaka to take the water level and river contour. So the support will hang with a long time period and also facing the wave. So it is very important the structure to be very high strength and durability. Second problem is inaccuracy data taken due to inflexible structure that do not stay within the water surface. When the structure is not flexible, the water level data will not accurate due to the sensor will lift out from the water while moving. The flexible structure will make the sensor be in the middle between underwater and water surface. Since it take water level measurement, so of course it will start from the water surface to the bottom of the river. Okay, next for the objective. The main aim of this research is to perform design on flexible structure for underwater sensor holder by choosing the best material and product flexible design. And second, to perform FEA analysis and design software with a minimum cost that will use CATIA as the software for drawing and analysis. Third, 3D printing with SLS capture the real test data. The SLS will use to fabricate the product. Okay, for the scope for this project, to make the flow more precise by starting with the literature study of lightweight, height, strengthness, and effect in the terms of failure. And the second is developed in design software, which is CATIA, and design optimization, FEA, finite element analysis, and critical area product of design, also by using CATIA, and print at a selective laser sintering SLS, and do real testing. Okay, for the literature review, the journal and research is about two main things that I focus, which are a past design for measuring water level and the best material selection, which is nylon P12, because these are the two things that need to be more focused for my project. There are a lot of methods to measure water level. The application is still same, either in sea, river, or lake. These three are the most famous and precisely method to measure water level. Okay, next. The invention of sonar, based on Kamalov and Park 2021. So this method using sound to measure the water depth by sending it a pulse move down to the water and bounce back to the water surface. And transducer is the device that used to measure the reflected or the time taken the sound pulse to reach the bottom and return. The depth of the ocean can be calculated by knowing the sound speed in the sea, approximately 1.5 kilometer per second. Okay, next, the lead line is one of the oldest measurement water depth instruments since 19th century. They use a rope to connect with the heavy chunk, and there is a hole inside the heavy chunk to fill up with something sticky like animal fat, so that when they pull up the chunk, they will see where or what the bottom they are in. The rope is marked with a 1 fathom, 2 fathom, 3 fathoms until 25 fathoms. Each fathom approximately 6 feet length. This old measurement method but still used in certain places to measure the water level so that the ship or boat doesn't stuck in the middle of the nowhere. Okay, the third method is type gauge. It's one of the method that all people use usually in the country that has a lot of sea and island like Hawaii and Indonesia. When water touch the device at the bottom of the pipeline, the electronic sensor will measure the height and send to the user. The information can be sent through a cell phone or any electronic device. Okay, for the material selection, height, strength, and lightweight for flexible structure is nylon P12. Why nylon P12 is chosen as the best material for this project? It is because since this project will be working underwater, all the characteristics that need have in this product like height, strengthness, and lightweight, durability, have in this material nylon P12. Second thing is chemically resistant and stress fracture resistant. Since this product will work in the water, and high chemical resistant are needed to prevent from corrosive, and chosen because of its potential to be sintered in powder form using a selective laser sintering process. And this material also semi-crystalline polymers exhibit great strengthness, fatigue resistance, heat stability, and outstanding surface resolution. It is very useful to use this material because of its strengthness combined with a good level of flexibility. They can be proved by experiment done by Ojoku and Hapsiken Chan in 2006. This is from their journal, Experimental Measurement and Finite Element Modeling of the Compressive Properties of Laser Sintering Nylon 12. Okay, as you can see from the graph, stress versus strain, we can see that the modulus is 741 megapascal, while the average compressive strength is 55 megapascal. For the modulus value is negative 740 megapascal, showing that the material is high strength, fatigue resistant, and flexible. Okay, this is my methodology for this project. There are 7 steps, and data collection and information until PDS have done in PSM1, and FEA until testing will be done in PSM2. For data collection and information, research about Sungai Melaka and past design for measure water level and what is hydro QS. For the literature review, find the related journal about measuring water level, the past design, and what is seismic sensor, what is hydro QS, material selection, and also SLS machine. Third is design ideas. Uh, Sketching 3 concept design with different flexibility and structure that I will be explained after this, more detail after this. And number 4 is PDS, product design specification, which is design have to go through the product design specification or analysis to choose the best design. FEA or finite element analysis, after done drawing in CATIA, analysis product design in FEA to detect which part facing height, stress, and strengthness. Number 6, fabrication product. After finished design and analysis in CATIA, fabrication product will be start in SLS machine and use SLS machine with material nylon P12. And lastly, testing, product functional testing. These 3 will be done in PSM2. Okay, this is a product sketching concept design. There are 3 concept designs. As you can see, every concept design have a different way to work and run, but still in a flexible form. So this is the concept design one. As you can see, there are 5 parts, which are G-clamp, support structure, stainless steel wire, cage, and seismic sensor. Okay, the function of G-clamp is to connect the portable support to the mini boat. Need to make a 2 root support because when the boat are moving, the angle of the cage will less than 90%, and also making the seismic sensor cannot read accurately. This can make the sensor stay in the Z direction. This design more likely to floating within the water surface. Then the structure is height in height strengthness. The stainless steel wire give more flexible and freely moving for the seismic sensor to take the measurement, while the cage protect the sensor from move backward or change in any other angles, so that the seismic sensor will stay in a Z direction. Okay, next concept design is concept design 2. There are 4 parts. Also, you will be using a G-clamp, flexible band support, flexible portable, and seismic sensor. Okay, this design using flexible curve support that will be bent easily. Meanwhile, the portable casing that holding the sensor are loose, and the flexible root that click with the seismic sensor. When put in the water, the portable casing will move along with the wave, can make the sensor more easier to take the data smoothly. Okay, so this design concept 2 more likely make the sensor move accordingly the movement of the wave. The flexible portable is holder for the sensor can make the sensor move up and down following the wave. So the sensor will be between the water surface and underwater surface. Okay, this is concept design 3. For the design only, we'll use 3 parts, product G-clamp, buoyancy flex arm, and seismic sensor. Buoyancy flex arm actually works like concept 2 design, which is very flexible and can bend in and bend down following the how much we want to bend the structure. So this design also will be using D-clamp as a connector to connect the boat and to the portable support. By using flexible buoyancy flex arm, the the buoyancy flex arm can bend out and bend in. This support concept, it will move along with the wave. As a buoyancy flex arm mounts are connected to the semi-sensor. So the buoyancy flex arm will also can bend down without fracture or attach, and this sensor also can move along with the wave. Okay, these are the three components that we'll use for this project, which is the mini river boat, seismic sensor. Seismic sensor is the sensor that will be used to measure the water level. And lastly, the plastic G-clamp. It depends on the product or the part. Either we want to print the new one or use the market plastic G-clamp. Okay, for the fabricate, will be used a selective laser sintering SLS machine. This 3D printing is manufactured by Frasen Model SSPO2P, located at our laboratory FTKMP lab in University Technical Malaysia Melaka. Then the material that we use is nylon 12 or PA12 nylon. So as the conclusion to summarize this presentation, the main objective is to produce a lightweight for flexible structure for underwater sensor holder and hope can pass the field. Hopefully, it can be beneficial to the both side, which is Perbadanan Pembangunan Sungai dan Pantai Melaka, PPSPM, and also university along the journey to complete this project in the term of knowledge transfer, experiences, and expertise. With this new innovation, hopes can give an accurate water level data and help the improvement of water quality of Sungai Melaka. That's all for me. Thank you.